Hi everyone, in today's video I will be teaching you about UML sequence diagrams. First I will start explaining what a sequence diagram is and what it is used for and its basic notations and the type of messages and the interaction operators used in sequence fragments, and then we will create an example of our own. Okay, sequence diagram is a type of UML diagram that shows how objects in a system or a classes within the code interact with each other. Particularly, these diagrams shows how interactions in the order they take place, or in other words, they show the sequence of events. They are primarily used by developers and business professionals to document processes or to understand the requirements of a new program. UML sequence diagrams are designed so that they can depict a timeline. Sequence diagrams is also known as event diagrams, as it shows how different parts of your system interact with each other over time. Basically, sequence diagrams track the messages sent between the components of a system. We can use a sequence diagram in several scenarios. For example, when we want to see the system functionality or to predict the object behavior. So with the help of sequence diagram, we can see what functions each object can perform and when. We can also use a sequence diagram for future system implementation. So when updating a pre-existing system, a sequence diagram is used. Now coming back to sequence diagram, the diagram flows descends downwards. And we used to mark all the sequence of interactions in a system. These interactions and objects have some symbols and notations. An individual participant or an object in a sequence diagram is represented by lifeline. So it represents the system components in your process. And next we have actor. An actor is used to specify a role that is either played by a user or any system that is going to interact with the objects of the system. And next we have activation bar. It is a box placed on the lifeline. It is used to indicate that an object is active during the interaction between the two objects. The length of the rectangle indicates the duration of the object staying active. In a sequence diagram, an interaction between two objects occurs when one object sends a message to another. So the use of activation bar on the lifelines of message caller and the message receiver indicates that both are active during the exchange of message. That is, the message caller is an object that sends a message, and message receiver is an object that receives the message. And next up we have message arrows. An arrow from message caller to message receiver specifies a message in a sequence diagram. A message can flow in any direction, either from left to right or right to left or back to the message caller itself. So with the different arrowheads you can indicate the type of message. The message arrow comes with a description on it, which is known as a message signature. These messages define the kind of communication that occurs between the lifelines. For example, a communication can invoke or call an operation using a synchronous call message or using an asynchronous call message. Also raise a signal using an asynchronous signal and create or destroy a participant. And here you can see the list of messages. With this we can communicate with the lifelines in an interaction. An object or a participant can be created using this message. This message is used when we create a new object in a sequence diagram. This is represented with a created word on the top of the dotted arrow. And this particular participant did not exist until the create call was sent. We can also delete the participants when no longer needed, and it can be deleted from the sequence diagram using this message. And this is done by adding an X at the end of the lifeline. And this message is called delete message, which is used to delete an object. Delete message is also known as destroy message or destruction message. The destroy message is represented by the keyword destroy. And next up we have synchronous call message. Synchronous calls which are associated with an operation and have a send and receive message. This message is sent from source lifeline to target lifeline. The source lifeline is blocked from other operations until it receives a response from the target lifeline. And next we have asynchronous call message. Asynchronous calls are associated with an operation and typically have only one send message, but can also have a replay message. An asynchronous message don't need a replay for an interaction to continue. Synchronous messages are usually drawn using a line with a solid arrowhead pointing from one object to another. Like synchronous messages, the asynchronous messages are drawn with an arrow connecting two lifelines However, the arrowhead is usually open and there is no return message depicted. And then we have asynchronous signal message. These messages are associated with a signal. A signal differs from a message, that is, there is no operation associated with the signal. A signal represents an interrupt or an error condition. Next, we have return or reply message. It is drawn with a dotted line and an open arrowhead pointing back to the source lifeline. Next, we have self message. It is a message an object sends to itself. That is, when an object sends a message to itself, it is called reflexive message or self message. It is indicated with a message arrow that starts and ends at the same lifeline. It is U-shaped arrow. And we have a found message. It is used to represent a scenario where an unknown source sends a message. It is represented using an arrow directed towards the lifeline from an endpoint. For example, consider a scenario of a hardware failure. It may be due to multiple reasons and we are not certain about it. And this is lost message. It is used to represent a scenario where the recipient is not known to the system. And it is represented using an arrow directed towards the endpoint from the lifeline. For example, consider a scenario where warning is generated. The warning might be generated for the user or the other software resources that the lifeline is interacting with it. Since the destination source is not known, the comment object is a rectangle with a folded over corner as shown here. The comment can be linked with the related objects with a dashed line. There are a number of mechanisms that allow you to add the logic to the diagrams, which comes under the heading of combined fragments. The combined fragment is one or more processing sequences which is enclosed in a frame and it is executed under a specific named circumstances. To create a combined fragment, select the combined fragment in Toolbox, drag it here over the diagram. You can change the operator by setting the interaction operator property in the property editor. A sequence fragment is represented as a box called combined fragment. The fragment operator, which is at the top left corner, indicates the type of fragment. Sequence fragments are used to show the complex interactions such as alternative flows and loops in more structured way. The alternative fragment is represented by a large rectangle or a frame, and it is specified by mentioning alt inside the frame's name box, also known as fragment operator. To show two or more alternatives, the larger rectangle is then divided into what is called interaction operands using a dashed line as shown here. The fragment types includes alternatives, option, parallel, loop, critical, negative, assert, strict, sequence, ignore, consider, and break. The alternative fragment is denoted as alt and it models the if-then-else constructs. Next we have the option fragment, which is denoted by opt. It models the switch constructs. And next up we have parallel fragment, which is denoted as par. It models the concurrent processing. Loop fragments encloses a series of messages which are repeated. And next we have critical fragment, which encloses a critical section. And this fragment can have only one thread executing it at once. The fragment must complete before another thread can run. For example, if an operation D is within the critical region and it is invoked, no other operation can be invoked until the completion of D. Next we have negative fragment, which shows an invalid interaction. And then we have reference. You can use the reference fragment to manage the size of large sequence diagram. It allows you to reuse the part of one sequence diagram in another. In other words, you can reference part of a diagram in another diagram using a ref fragment. And next up we have weak sequencing fragment, which is denoted as SEQ. The weak sequencing interaction operator adds order to the interaction in a fragment based on their placement. Weak sequencing allows partial parallel execution but controls the order of events on the same lifeline from different interactions. Next, the break interaction operator, which is similar to break mechanism in other programming languages. The interaction operator break represents the breaking or exceptional scenario that is performed instead of remainder of the enclosing interaction fragments. A break operator with God is chosen when the God is true. When the God of the break operand is false, the break operand is ignored and the rest of the enclosing interaction fragments proceeds. Next, the strict interaction operator. The strict interaction operator requires the strict sequencing or ordering of the operands on the first level within the combined fragment. And next up we have consider. This consider operator defines which message should be considered within the combined fragment, meaning that any other message will be ignored. Consider operation is typically combined with other operations such as assert, consider. The interaction operator ignore defines there are some messages that are not shown within the combined fragment, and these message types can be considered insignificant. The ignore fragment declares a message or a message to be of no interest if it appears in the current context. And these ignored messages are enclosed in a pair of curly braces. Ignore operation is typically combined with other operation like assert, ignore. And finally we have assertion fragment, which is denoted as assert. This interaction operator indicates that an interaction operand is the next sequence in the interaction fragment. And this is SD, which is used to surround an entire sequence diagram. And so far we have seen what a sequence diagram is and its basic notations and the type of messages and the interaction operators used in sequence fragments. Now let's see an example on sequence diagram. First we need a topic. For example, let's diagram the interaction that happens at an ATM. So in our case, what are the parts involved in an ATM transaction? A person goes to an ATM to get a money. The ATM communicates with the bank server and that person's bank account is then accessed. The ATM, bank server and bank account are all part of ATM system. These three items are our objects. The person, on the other hand, is external to the system. Therefore, they are an actor. Actors are always outside the scope of the system. In a sequence diagram, actors are represented by stick figures and objects are represented by rectangles. So first we will drag out an actor and place them here on the left. This represents the person is trying to get money. Then we will add our objects alongside it. Then we will name this object as ATM. The person first interacts with the ATM, then bank server, and finally bank account. The objects to be placed in a sequential order from left to right. Next, we need to add lifelines. Lifelines are the vertical dashed lines that shows the existence of an object or an actor over time. Moving down the lifeline means the more time is passing. So we will drag out a lifeline for an actor and for each of our objects. Now we have our basic chart laid out. We can start to diagram the interaction between our actor and our objects. The first thing you need to do when you go to an ATM is insert your card. That will be our first message. Messages show the information being sent between the objects. Sequence diagrams show the order of interaction or sequences, and they do this by moving down the lifeline with each message. So we will start the first one at the top. Drag out a line that connects the actor lifeline to the ATM lifeline. Now give it a label as insert card. Next, the ATM checks with the bank server to make sure it's a valid card. So we will drag out a line and place it between ATM and bank server. And it is drawn just below the previous message line. We will label this one as verify card. The server verifies the card and sends a message back to the ATM. When an object sends a message back, this is called return or reply message. And they are always represented as a dashed line. The return lines often move from right to left. So we will drag out another line and connect it from the server lifeline to ATM lifeline. We also need to change the line from solid to dashed. Again, the dashed line represents a return message or a message from receiving object back to the requesting object. Now we will label this message as a card working. After the card has been validated, the ATM will ask for a PIN. So we will draw a line from ATM to actor and label it request PIN. And note that this message is not a reply to an earlier message and it is a requesting information. So this message is not a reply message and it will be denoted by a solid line. So what happens when the card is invalid? Like when an inserted card is expired. This is when an alternative frame is used. An alternative frame symbolizes a choice between two or more message sequences. These choices are usually mutually exclusive. So in this case, the conditions are if the card is valid or if it is not. So we will drag out one of these boxes and place it around the two messages we just created. The upper portion of the box will be labeled if card is valid and the lower portion will say else. And this says if the card is valid, tell the ATM and the ATM will request a PIN. The card is not valid, the server will tell the ATM and the ATM will eject the card. We will make two more messages that shows the alternative interaction and labeling them as card invalid and eject card. After the ATM has determined the card to be valid and request a PIN, the user will input their PIN. Since the ATM requested the PIN and this is the user response to that request, and this message will be the return message. So we'll make a dashed line from the actor to the ATM and label it as PIN entered. The ATM will then ask the server if the PIN is correct. So we will draw a line to represent that interaction and label it as verify PIN. Now we have the same situation as before where we need to use an alternative frame. First, we will create what happens if the PIN is valid. The server will tell the ATM the PIN is valid. And the ATM will ask the user how much cash they want to withdraw. So we will drag out an alternative frame and place it around the two new messages. And labeling the top portion if PIN is valid. Next, we will add the alternative messages. The server will tell the ATM the PIN is invalid and the ATM will eject the card. We will continue to map out the rest of the interactions by creating messages and return messages until the transaction is complete and the actor has received their money. Now the user will input the amount and ATM will start the transaction with the server. The server then asks the bank account if there are sufficient funds to cover the transaction. If the funds are sufficient, the server will withdraw the amount until the ATM to dispense the cash. If the funds are not sufficient, then we will get an alert message and the transaction will be unsuccessful. Finally, the card will be ejected after the cash is dispensed or the transaction was cancelled. With interactions complete, now we can add the activation boxes. Activation boxes show when and how long an object is performing a process. That is, it shows us when an object is active and when they are idle. So we will drag out and place it on the ATM lifeline and fit the box around the first and last message on the lifeline. We will do the same for bank server and bank account. As I mentioned earlier, actors are external objects, so they don't need an activation box. Now we can easily see that the bank account is much less active than the rest of the objects in the sequence. And this example is fairly simple. Sequence diagrams can get even more complex. For example, if you are diagramming a code, the objects might be labeled as names of classes, and the messages might be the methods and functions used in a code. It all depends on what you need to diagram and how complex you need it to be.